Good afternoon, everybody. It's lovely to see you all here today, joining us for the second session in our series with the Internet Archive, DWeb, and Library Futures. The entire series is titled Imagining a Better Online World, Exploring the Decentralized Web. And today we'll be talking about using the decentralized storage to keep your materials safe. My name is Davis Aaron Anderson. I'm Assistant Director for Programs and Partnerships at Metro. Please say hello in chat. We'd love to know who's out there. Where are you from? What's your name? What's your interest in this topic? We'd love to know who's in the audience and hear from you a little bit as we get started. So Metro is a multi-type consortium. We serve the 5 boroughs of New York City and Westchester County. We're a service provider. We do events like this and partnership programs like the one you're attending today. We have a group that works on software development. We provide delivery services and make sure that knowledge can be spread equitably throughout our service area. So we really care a lot about the future of how information moves. And so we are pleased and honored today to support the work that the folks are doing at Internet Archive. We wanted to hear a little bit more about what they envision for the future of the web. So we're running a 6-part series. This is the second part. We'll drop a link into chat that lets you see where to go to register for our upcoming sessions, as well as check back on the resources we're providing for this one and the past sessions as well. So if you would please drop your questions into chat and your comments as well. We had a really robust and active conversation going for our first session, and we'd love to see that happen here again. We're also providing resource guides to go with each and every one of our 6 parts of the series. So please also look at chat for a link to the current guide, and please stay tuned to your inbox. If you registered, you'll receive a PDF copy as well. So it's my pleasure to introduce you to Wendy Hanamura. Wendy is Director of Partnerships at Internet Archive. She planned the first ever Decentralized Web Summit a few years back. In the past 6 years, she's helped to guide the global growth of the decentralized web, so she's really the expert on this topic. And she's here today to co-produce the 6-part series, Imagining a Better Online World, Exploring the Decentralized Web. So thank you so much, Wendy. Over to you, and great to see you again.
Thank you, Davis, and thanks to all of you for being here today. I'm seeing friends from Berlin and Argentina, many from New York and Florida. We're so happy that you can be here to learn a little bit about decentralized storage. Now, in this webinar, we're going to be exploring with you a new set of decentralized technologies that may help you to preserve and provide access to your media. So here's the game plan for the next 60 minutes. I'm going to start by giving us an overview of some of the problems that decentralized storage could help to solve. Then I have invited a friend of mine, the founder of Starling Lab, to share with you how his group is working with many cultural institutions to keep their most critical and important materials safe. We also want to show you this tech in action, so I've invited 2 people to demonstrate what they've been working on. First, an engineer of ours from the Internet Archive is going to be showing you how we've been experimenting saving web archives at scale in Filecoin. And a senior engineer from the STORJ, Decentralized Storage Company, is going to show you how we've been storing LibriVox audiobooks in decentralized storage. Now, both of these collections, the web archives and the audiobooks, were created collaboratively by communities. And I think that's the real promise here, that you could take collaborative collections and perhaps store them and preserve them collaboratively as well. So let's start by thinking about some of the challenges. Now, many of you are archivists, you're librarians, you run cultural institutions, so this is very familiar. Your collections are ever expanding in the physical world, but also in the digital realm. Digital objects may be even harder to store, right? How do you keep things safe, not only from floods and fires, but also secure from hackers? How do you make them accessible in a time when there are broken links and content drift? How do you make sure that your data is trustworthy, especially in an era when deep fakes are growing? Then there's the scale of digital holdings, which seem to be enormous. And isn't it true that weeding digital objects feels a little bit wrong since they're just bits? How do you weed ever-growing digital collection? And what about the long-term preservation, the sustainability of this collection? How do you do digital storage in centuries? And let's not forget the issue of cost. It is so hard to predict the future costs of decentralized storage, especially when technology is changing all the time. Now that takes us to this. Think of the decentralized web as a stack, with every layer of the web stack potentially decentralized. When you take all of these decentralized technologies together, that's what we call the decentralized web. And you'll notice in this diagram that the bottom layer is decentralized storage. That's the layer we're going to be exploring today. Conceptually, decentralized storage allows you to store your data across a peer-to-peer network of servers. But so does Amazon Cloud, right? So what's the difference? Well, I would say that the difference here is really that not only is your storage location distributed, but also your storage management is decentralized. That way, you can't take out just one central control entity like Amazon and have the entire system go down. So what is the promise? What does decentralized storage offer? Well, first, there's the concept of resiliency. Now, we're very familiar with that in the library world. There's locks, lots of copies keep things safe. So we know that if you distribute copies across different geographic lines, geopolitical lines, it's going to be safer. Then there's the concept of persistence. Now, this is something that a lot of people get wrong when they think about the decentralized web. Just because you cut up a file and put pieces of it in different servers does not mean that those servers are guaranteed to keep your files forever. No, persistence would mean that you'd have to have a guarantee somehow built in that the people who hold your copies will hold them forever or for a long time. So how do you ensure persistence? Well, in truth, I don't think we're really sure about that. But organizations like Filecoin and STORJ are using a combination of incentives and shared protocols and contracts to try to ensure persistence. Next, I think this step, self-certification, is the most important attribute of decentralized storage. You know, here, every item is assigned a unique immutable hash, a persistent ID. And you use this ID to find your things wherever they are and to copy how many people have, to check how many people have copies of them. So this is something we call content addressing. And in Web 2.0, you find things based on where they're located, right? You have a URL that takes you to a place on a server. Well, in Web 3.0, or the decentralized web, the ID remains with the content itself. And if the content changes, so does the hash. So anytime something is altered, you get a new hash. And ostensibly, this self-certification is what allows you to ensure the provenance and authenticate an item. Finally, there is the goal of interoperability. I think it's pretty true that right now we have a lot of silos where our materials live. And when you want to work collaboratively on a shared data set, that can be very problematic. Now, in the utopian version of decentralized storage, you can have collaborative, authenticated, co-hosted collections. And these collections would be less prone to censorship because you can't block just one URL and block the entire collection. They're also perhaps harder to hack because there's not one single honeypot to go after. They may be easier to share. Taken together, resiliency, persistence, self-certification, and interoperability, that is the promise of decentralized storage. But it is still early days, so whether or not we can deliver on those things is something we're testing. Now, it is my deep pleasure to bring on Jonathan Dotan. He's the founder of Starling Lab, which is the first major research laboratory devoted to Web3 technologies. It's affiliated with Stanford and USC. And I know that Starling has been working for quite a while with the Shoah Foundation to make sure that Holocaust testimony videos are kept safe and persistent. But here's a fun fact. I first met Jonathan Dotan back in 2018 when he was the consultant for HBO Silicon Valley. And it was Jonathan Dotan who convinced the showrunners to introduce a storyline about a new internet, a decentralized internet. And that's how he came to be involved with us at the DWeb community. So welcome, Jonathan Dotan, founder of Starling Lab.
Thanks so much, Wendy, for having me, and to the entire community that's assembled here. I can't think of a more appropriate group of folks to be speaking to about decentralized storage, because certainly the power of archiving institutions and libraries and providing a new layer of trust for communities in preservation is unique. And I'm really excited to help bring you into the fold to help answer any questions and potentially even inspire you on the possibilities. At the Starling Lab, we've been working on what we call a framework for data integrity that allows you end-to-end to think about how you capture, store, and verify information. And the page that we really are working from here is one that was written many years ago. So I want to start with a little bit of context today, share with you a prototype of some of the early work that we've done, and then get into some of the learnings and how they might apply over to you and some of your archival use cases. So to begin, Wendy's talked a little bit about the goals of decentralization, but I want to start even a little bit more upstream from there and just get into a very simple, but also I think poignant understanding of how decentralization works. In the prior view of communication systems, when let's say AT&T as an example was a dominant form of guaranteeing communications infrastructure, you had to rely on AT&T as a centralized node, right? To basically all the data went into AT&T and then went out of AT&T in order to be passed along in the case of something like voice communications. The distributed web was something that was not actually done, let's say in the 90s when the web took off. It actually was a part of the original architecture of the internet. And when Paul Barron over at the RAND Institute set forth how a digital network of this kind might work, he explained that what was critical was to establish nodes that were interoperable. So that meant that if any of those nodes went down, they could be replaced and function by the others, that there was neutrality, that the network itself didn't discriminate, but simply passed along the information. And that meant that you could allow the end user to hold all of the intelligence and the rich applications that might exist on this type of network. And so this concept was really baked into a larger philosophical framework that was put into play by Doug Engelbart and the team over at the Augmented Intelligence Framework. And what it posited is that for a decentralized network of knowledge to exist, you needed to have, at the ends, computers that could be used by the average user. So a personal computer and the concept of the internet were actually birthed out of the same framework. And that's not actually commonly understood, but it makes sense on many levels. And as you look at the history of the web as it took off in the early 90s, it's no accident that the first HTTP server was actually a personal computer. And funny enough, this is Tim Berners-Lee's machine over at CERN. You can see there's a sticker that said, to clarify that this is not just a personal computer, but it's actually a server. And he explained to people that they shouldn't turn off this machine because it was, it was basically hosting information. So from those early promising visions around decentralized technologies and how one might want to build a global internet infrastructure, there's a growing realization that now, as the internet has taken off and working at scale with so many parts of our lives touching it, that something really is amiss. That as the internet has become more centralized and dominated by corporations that have often monopolistic practices, that there's been tremendous issues with establishing trust in this type of system, and that we might want to return to decentralization to restore trust and to restore a sense of fairness within the internet. So that's where a lot of these ideas are coming from. To be clear, this is actually how the original internet was designed and meant to be. The Decentralized Web Summit in 2018, which is how I got really into the fold, was a program that was hosted by Wendy and Brewster over at the Internet Archive. And it was really transformative in bringing a number of different individuals together to think about these issues. And it's important to mention this type of, the importance of this event. It was really that it was a cultural event as well as a technical event in which people were thinking about shared values that were distinctly different from things that you may have heard of around blockchains or cryptocurrencies. This was really a group of people that were concerned with how do you guarantee access to knowledge and how can you use decentralized technologies for things like preservation, which is our topic today. So the Starling Lab came out of really that rich tradition. And in working with the USC Shoah Foundation and Stanford's Department of Electrical Engineering, we've found this incredible opportunity to bring together experts to think about how we can deploy decentralized technologies to advance human rights. So we work with a number of different industry partners, and really the founding work and research that we did was with the USC Shoah Foundation's Visual History Archive. As Wendy mentioned, this is an archive that deals with the testimony of the survivors of genocide. It started 30 years ago by cataloging the stories of survivors of the Holocaust, but it expanded, and now they're working on, I believe they're on their 14th genocide collection as of last week. And sadly, of course, that number continues to increase. There are over 55,000 survivors' testimonies. On average, it's about 2.5 hours and several gigabytes for every testimony. So it's a massive 4 petabyte collection. And currently it sits in 3 different data centers that are all state-of-the-art tape-based archival systems. But in working with them, we've really reimagined a continuum of preservation that goes beyond just their data centers that are maintained by the USC Shoah Foundation. Bravely, their CTO, Sam Gussman, has been working with us on figuring out a way to take the entire 4 petabytes of the Shoah Foundation's archive and put it onto the distributed web. And then in addition, I should mention that he's also looking at longer term media storage, like storage on silica and DNA, et cetera. So they're quite innovative and progressive in thinking about preservation. The type of content that we've been working on is in looking at genocide testimonies. We've expanded our testimony collections with them to understand how the whole life cycle of testimony is collected and preserved and indexed. We've gone to Iraq, Los Angeles, the Amazon rainforest. We've been working in Syria on preserving testimony of that can be potentially not only useful for humanitarian causes, but also for accountability as well. So we look at preservation for those purposes. And finally, we've been working with news organizations like Reuters to look at their archives. And most recently, we finished a project with them last year called the 78 Days, which cataloged each of the 78 days between the election and the inauguration. That included January 6th as well. What we found is that really what we're creating as a set of solutions is not just centered around preservation, but it's also around restoring trust. And so what I want to show you today is how we think about how that might work end to end. And really, it begins by following the natural life cycle of how you go and generate data, which would start with capturing. And then you move to storage, and then finally, verification. And it's with each of those steps that are critical to ensuring that you have a data set that could be trusted. And what I want to show you today is how decentralized systems can actually guarantee trust at each of these 3 stages. So let's begin with capturing on something like, let's say, a mobile phone. In our case, what we've done is we've taken not only the phone's ability to take a photo, but also looked at all the other sensor information that exists on the phone, like GPS for location, network information to establish relative location, the gyroscope to understand the relative position of the camera, and even things like time and date, right? These are all critical pieces of metadata that the phone is able to generate. What we do is we take that metadata and we pair it with the image so that every time that you take a photo, you now have the payload, not only of the image pixels, but also of this metadata. Now, through our process of working with HTC, we've been able to take this payload and do something really special with it on the device, which is that we first of all create a hash of it on the device itself. And then we sign that hash with a cryptographic key that is guaranteed by firmware, which is on specialized hardware within inside the phones. So what that means, really simply, is that now you have a unique fingerprint of both the image and the metadata, and we've signed that so that we know that that fingerprint is secure. So with that payload of preservation information and all of the metadata, we now take it and we put it on the decentralized web. So that step begins by first creating a CID, which is a unique identifier for that payload. And then we spread it out across the decentralized web, basically splitting up into different pieces. And there we can store it onto different types of nodes. So you could imagine academic institutions, nonprofits, enterprise cloud, even small devices like the Raspberry Pi, or a personal computer, even a phone. All of these different nodes are, in our minds, appropriate for storage because we want to diversify storage. And that's really critical to our framework. In addition to that, we use cryptography and advanced proofs of space-time, like the kind that Filecoin has, an example, to ensure that as you spread information far and wide, you're also ensuring that its integrity is kept. And that if any of those nodes which takes the data manipulates the data, we now have a way of proving that, in fact, that manipulation has occurred. Paradoxically, what this means is that as you spread information farther and wider, not only are you able to preserve the information better, but you're actually able to create a seal around the information. And with more and more nodes joining that network, the harder it is to break that seal. So that's our preservation story. But as you all know, in working in the archival space, it doesn't end there. Just because you have a record of something that you prove has not been manipulated, still the contents of the objects matter to be, they need to be examined and they need to be indexed. And so the expert certification of the content of information is something that is normally done through an archival process of indexing and verification. So we take those attestations, and those two, we also put those on decentralized systems so that those records of the authenticity and the verification of the content itself can also be preserved on a decentralized system. So that becomes basically the three parts of our system: capture, store, and verify. So as a last step, I want to show you where all this stuff is stored. In working with Adobe and Microsoft and the Linux Foundation, we've been helping pioneer a set of standards called the C2PA, which allow you to take all of this information and actually put it directly, as an example, with a JPEG inside the photograph itself, so that now the photograph becomes a universe of information, not only of image pixel data, but also of these cryptographic proofs and also of these verifications. So now if, for instance, I, in this example, can use a small app, I can click on this eye and I can see all of the information around the photograph and its metadata. And I can also see the links back to where this information sits on the decentralized web. All of this just contained inside of the JPEG. So we think that's pretty nifty because it now changes every photograph from being just a photo, a container of image pixels, to now being a universe of information for fact checking, for image verification, et cetera, et cetera. All right, I'm going to close very quickly by just going through our prototype and some of our learnings. So I described to you a little bit about the work that we did with Reuters, but it really was an unfolding set of experiments during the course of the 2020 election. And what we did is we used our technology to go out with photojournalists at Reuters, and I'll show you end to end how we established this new form of digital trust. So it began by having photos from this professional grade camera move over to the phone, where it was notarized through the process I've described. And then it ends up in the CMS system at the Reuters headquarters at their photo desk in London. And then from there, we took that information, which included, again, not only the photo, but also things like location and a hash of the image, all that complex metadata. And we were able to syndicate it out to different decentralized systems. So in this case, the first step was to syndicate it out to a private permission system with IBM. So this is a form of blockchain technology that's called a private permission ledger. So that's the first step. And then the second step was we put it on a public permissionless ledger, which is similar to something you can think of almost like Bitcoin, where we were able to store a hash of that information also out on the public web. So this allowed you to preserve privacy and also have a public system of verification. I think we could have never imagined what we were actually going to capture during those 78 days. I think they caught all of us by surprise in terms of how historic they proved to be. But what I can say is that the efforts of our technology development were certainly on, they weighed very heavily with us as we thought about what we were doing and helping think about the restoration of trust. Because surely I think we can all agree, no matter what side of the aisle we're on, that the demonization of the free press is something that we should all strive to end. And hopefully the work that we're doing in creating an archive that can sustain the challenges of misinformation and the challenges of manipulation through social media is a really good step in that direction. And so you can check out the website yourself, starlinglab.org/78 days. I'll give you a chance to play around with the archive and also see more in-depth explanations of the technology. So I'll wrap up here with the last minute about our learnings. You matter. That's probably the biggest thing I can mention, which is that institutions like libraries and archivists are a key part of creating a solution that is networked, and that as a community, if we can all come together to guarantee the integrity of information, we're in a unique position to create a new foundation of digital trust. So it takes that form of collaboration, and that really when we think about decentralization, it's not a single destination, but it's an unfolding process in which we continually strive to bring more and more diverse nodes into our system. And the more diverse those nodes are, the more that they're going to be able to store and verify information. And so that's really why you might think of multiple ledgers and multiple decentralized systems coming into play, because they can allow for a tremendous amount of diversification of cryptographic features, of performance, methods of preservation, and last, of course, diverse views. Think of decentralization a lot like biodiversity. This is how we get resilience as a community, and both at a technical level and also at a community level. All right, with that, I'll pass it back to Wendy. Thanks so much for having me.
Thank you, Jonathan. We have some questions, some really good questions. So one question is, how does this differ actually from BitTorrent, which is a very good question?
There's a lot of similarities, actually. So BitTorrent works by syndicating information across multiple different nodes. Some of the big differences in our work is that we choose nodes. So whereas BitTorrent is meant to be diffuse and random with how information is spread across, and it's optimized basically at the protocol level, we think about the decentralization process as something that we want archives to have a role in choosing which nodes they distribute their information. And so that's a major distinction.
Is your tech open source, and can you point us to a GitHub?
Yes. So to be clear, we've implemented open source technology, and our prototypes are, we're in the process of putting out various parts of our code base. But really, we haven't created any novel technology. We've just created novel implementation. So I'll be very happy to refer you over to our website. And if you want to reach out, I can give you a list of the different protocols that we've used, and all of those are open source. And we are very firmly committed to being a part of an open source ecosystem, both as contributors and also publishers.
So Jonathan, what's the name of that JPEG embedded metadata standard? Librarians are very keen on helping to create better metadata.
Sure. So the link is actually there. I see Heather's put it in, which is the C2PA. And I'd really, there's a very welcoming and open environment there for people to weigh in. I think archivists are a key part of helping us come up with a standard that's going to be useful for them. So we'd be really happy for people to contribute to that standard. And it's based out of the Linux Foundation, so it too has open source commitments.
So someone said, are you licensing software?
As an organization, no. We're a lab that's experimenting to help create a sense of the art of the possible. And we have various partners that we work with. Almost all of them are fully transparent and open source in their work. That's a key criteria in working with them. And in that way, there's really no complexities with the licensing. You can use it, you can fork it, etc.
Nicholas Taylor mentions that I had brought up the incentive and contracts as mechanisms for ensuring persistence. Can you elaborate on how persistence is assured or supported in the Starling frameworks?
Sure. So remember, we're a framework that allows you to help make better choices, and we use a variety of different protocols. In each of those protocols, we don't endorse them as best practices, but we're experimenting with them to understand how they could achieve persistence. I'd say that if you look at currently what's out there, I'd caution people that there are some big promises that are being made about immutability and persistence and permanence. We as a lab try to avoid those words, because we're concerned that with any of these technologies and communities, history shows that really nothing can be guaranteed to be permanent. And so it really takes active efforts to ensure that type of thing. Now, what's new is that you really have these incentive layers that could potentially allow people to think about the creation of endowments, for instance, that could persist for years and years if they're properly architected and if the economics bear out. So in all the cases, whether it's Filecoin or Arweave, people from STORJ are here as well. They can talk to you about how you can use some of those incentives to help ensure that people that are hosting information are incentivized to do that long term. But the reality is that that's never a passive effort. The data owners and the archivists like you have to be involved in helping architect some of those best practices. And you shouldn't gloss over the details because it's really important that everyone understand what are the incentive mechanisms and the security mechanisms there.
We have some very knowledgeable questioners here. As Kiernan says, is someone more familiar with LTO storage and trusting the hashes in bag manifests? Is the idea here that these are not trustworthy enough in certain contexts?
To be clear, I'm not as familiar with LTO storage, so you can help enlighten me, Kieran. But what we found is that typically most archiving organizations will just have hashes. They'll just store hashes like a SHA-256 of their underlying data. And that is not enough, because unless you sign that information, you really don't have a way of protecting those hashes and ensuring that they have integrity. So we're providing not only a hashing, signing, but then also a way of putting that information on a decentralized ledger. So think about it as like the belt and suspenders in this case. So we're not taking anything for granted about the integrity of the hash. Instead, we are finding multiple layers of trust that we can put on top of the hash so that we can all ensure that when we look back, let's say in 50 years, that we know that that hash was actually properly created and it was secured over time.
Jonathan, I don't know if you've ever thought of this, but you're speaking to a lot of people from memory institutions like libraries, museums. Looking in the future, where do you see decentralized storage applied in their world?
I like to think about it when I talk to the folks at the Shoah Foundation who are on the archiving side. I like to put their mind at ease and say, I think this is a backup to the backup. And what I mean by that is a starting point is that this is really cold storage and it's diffuse. So that means it's going to take time to reconstitute these types of archives if we need to have a restore event. And that's okay, because actually that's a great form of resilience, is to think about how you can diversify organizations and geography. And if that takes a little bit longer to get this backup of a backup back in your hands, I'd argue to you that that's still really valuable. Having been part of many technology organizations over the last 20 years, I can't tell you how many times we've been in a situation where we've trusted our vendor and trusted all the preparations we've made. And in the end, the server that was still standing was the one that was offline in the middle of nowhere that someone forgot even existed, right? Those are the types of things that can be essentially that type of serendipity is something you don't want to bank on. Instead, you want to actually think a little bit ahead. And these types of systems right now in their current state really can function in that way. They can be part of, I would say they're outside of your traditional and your performant forms of storage, but instead are a new way to think about preservation. And as these technologies get more mature, then we can start to move them up in our priority and reliability.
Thanks so much for joining us and for the great work you're doing with so many different organizations.
Likewise, Wendy, we're always inspired by you as well. Cheers. Thanks for having me.
Okay, well, let's go on to see some demos. I mean, what Jonathan was talking about was cold storage, but what if you wanted active storage at scale? We're going to be showing you two projects that try to experiment with that. First, I'd like to introduce to you Arkadiy Kukarkin. He is one of the top DWeb engineers working today, and we are so honored and pleased that he works with us at the Internet Archive. He was the founding CTO of an organization called MediaChain, which used blockchains to authenticate the provenance of music. And he also worked for Protocol Labs, which is the parent company of Filecoin. Now, we gave Arkadiy this experiment to work on. Could you take a different type of data file, in this case, WARCs or web archive files, and could you store them at scale across the Filecoin network? And we chose this collection, the End of Term Archive from 2016. Now, that was at the end of the Obama administration, the beginning of the Trump administration, and it gathered together the entire federal presence, every .gov and .mil website at that time. It was a collaborative collection. The Library of Congress, Stanford, California Digital Library, and many institutions worked together with the Internet Archive to pull this together. It's about 200 terabytes large. Now, if you were going to replicate it 3 times, that's 600 terabytes you need. It's about 20,000 items, 1 million files, billions of individual URLs. So Arkadiy, can you show us how you've been doing?
Hello. So my name is Arkadiy Kukarkin, and I'm going to show you how our experiment here is going so far. And let's just get started. So we use 2 technologies here primarily, IPFS and Filecoin. IPFS you can think of as a way to locate and retrieve content through a peer-to-peer network, and Filecoin you can think of as a way to ensure, or at least attempt to ensure, the long-term preservation of that content. So Probably the best way to dive in is to just look at a simple example. So I have here IPFS enabled in my browser. I'm using Brave, but you can also install an extension to do this in any other browser as well. And we can take a look at my node here. So here's some stats, but the most interesting thing is probably the peer list, which may take a second to populate. But you can see I'm connected to almost 1,400 peers throughout the world. And as they're coming up now, we actually see some in Russia and Ukraine as well, which is an interesting demonstration of the resiliency of these peer-to-peer connections, because as you know, web traffic to those places is currently disrupted. So let's take a look at just a simple image file here on the Metro website. We can import it into IPFS just like you could any normal file. Okay, here it is. And let's take a look. So IPFS, bam. So here's our image, and you can see sort of funny looking URL here at the top. Hopefully you can read that. But instead of HTTP, we have IPFS, and then we have this sort of scary looking long identifier. And what happened here is that the file was loaded into my local node and hashed and made available to the entire IPFS network. So if anyone pretty much anywhere in the world were to enter this IPFS URL, they would be able to access this file, maybe from my machine, maybe from another machine that also happens to have the same one, maybe from an intermediate node, someone in that network of 1,400 machines that I've showed you. So I think this is already cool because you're able to access a file simply by its identifier, the CID that Jonathan mentioned already, without knowing or really caring where it came from. The reason that works is that the CID is actually, well, it's a little bit truncated here, but this long string is in fact an encoding of a content hash, which again was mentioned by Jonathan. So we're not applying as rigid of a standard here. So it's not a sign hash, but nonetheless, if you request this particular identifier, you are pretty much guaranteed to get the exact same file back. So I think that's already pretty cool, because if we think about something like the lifetime of hyperlinks in a research paper. So this is just the graphic I pulled down. So after just a few years, something close to 50% of all hyperlinks across academic papers are no longer resolvable. And maybe they exist elsewhere. Let's say the Internet Archive has archived a copy in the Wayback Machine, or someone else has a copy, but the actual link is broken and needs to be manually fixed or followed, and trust to be ensured. So imagine the same paper using these references instead of a traditional URL. It will just work as long as another copy is available in the network. So let's move on to a real example. So the data set that Wendy mentioned is the end of term web archive. We're using the 2016 version, which I think is probably a relatively hot set, as it were. And here's a copy that's just available on the web, and you can load a page here. It's a little bit slow, but here we are. Here's the Indianapolis FBI Bureau in fall of 2016, and here's what the backing data looks like. So this is just a whole lot of basically gigabyte-sized work web archives. And so just as before, we have the CID identifier, and we can pull it up. And in fact, we can actually load it into some tools that have already added IPFS loading support. So here's a replayweb page, which is actually just a static file that loads from IPFS itself as well, and lets you browse the collection. So that's already pretty cool. So if you're a researcher an archivist, you may already de facto have a copy of this, having accessed it. So we have lots of copy, they're keeping stuff safe, but is it safe enough? I think in this case, it's actually probably not the case, because this is important data, but it's a very large amount of data, and it's data that will probably sit around not looked at for the most part until you actually need it. So what do we do? Well, one solution is Filecoin. So we're using a tool called STORJ. STORJ is one of several clients for the Filecoin network, but what it does is essentially manage storage deals within Filecoin. With the Filecoin basic primitive is a deal, and it is made between you as the client and any number of storage providers. Here is a global map of the storage providers online currently. And at the end of the day, I care about where they're located, but because of the promises of the network and the protocol, I actually don't care who I'm talking to exactly, because the storage integrity is a protocol level primitive. So here we have a 3x replication across some files, and we can take a look here. So the bright green is fully online, and some of these others had actually shown storage faults, and the STORJ system has now gone ahead and recreated these additional replicas. So they're now in the process known as sealing. And we can take a look. So here we have a provider. The provider, I don't actually know much about them, but we can take a look where they are. And this is a replica that we have in Montreal. So that's great. So I'd like to make a very quick note here, which is that coin might make you think of energy usage, of danger to the environment, and that is a very reasonable concern. So the important thing to realize with Filecoin is that it does not use the wasteful proof of work mechanism of Filecoin. The actual ongoing data verification that happens at the protocol level also ensures the integrity of the network. You can read more about it here at this link, and you can look at the volunteer energy disclosures at filecoin.energy. So of course, there are many other systems that attempt to solve these problems as well. So there's IPFS cluster, which is a sort of collaborative backup solution. There's Textile, which is another Filecoin client tool. There's STORJ, which will be right up next. There's Arweave, which aims to achieve a long-term or potentially infinite storage with a finite upfront cost, which is an interesting economic experience, and many others. So you can try this out yourself at storj.tech, which is a public STORJ node that's already hosting hundreds of terabytes of data for its users. And I think that's it. Thank you.
Thank you so much, Arkadiy. You'll be hanging out with us later if people have more questions, and you could probably answer some questions right there in the chat, and we're going to come back to questions with you and Dominick. So let's move on, though, to our second demonstration. I'd like to introduce you to Dominick Marino. He's the Senior Solutions Architect of STORJ. STORJ is probably the oldest decentralized storage company out there. And with STORJ, the Internet Archive has been working to store LibriVox audiobooks at scale. So here to show us how that work is going, please welcome Dominick Marino.
Thank you so much, Wendy. Very excited to be here speaking with everyone today. I'm Dominick, Solution Architect at STORJ, and we're one of the leading providers of decentralized storage. We're very proud of our track record over the last, oh goodness, it's been about 8 years since Sean Wilkinson founded us in 2014 in his dorm room. We've been really excited to work with the Internet Archive on decentralizing the LibriVox audiobook series. It's a collection of over 16,000 titles and approximately 22 terabytes of data. I've worked very closely with Arkadiy and have had a great time learning with him as we grow this at scale. bringing these massive collections into storage. And I'm happy to show what we've done today. The first thing I'm going to do is tell you what we've done, and then I'm going to show you how we did it, give you an explanation of how our network functions. So over at STORJ, we're a decentralized storage provider with over 13,000 nodes on our network, of which over 9,000 are independent node operators. When you upload a file into our ecosystem, you encrypt it, then you split it, and then you distribute it out to those tens of thousands of nodes. This gives you ultimately the consumer the control and allows you to remain, if you choose to, the custodian of the private key. We do, in full disclosure, work in both the Web 2 and Web 3 space. So we're engaged on a daily basis in Web 3 related activity, projects in the space, as well as offering edge services that allow organizations in the Web 2 space to benefit from the inherent benefits of the Web 3 space, meaning you can have a product today that uses something like Amazon's S3 storage, and you can benefit from the resiliency, the redundancy, the performance, the value that decentralized storage brings you, still in the Web 2 space. So we're really focused in pushing forward, in being forward-leaning, but still being able to have a very usable service by all different sorts of orgs. I'm going to jump right into a quick demo and show you some things we've accomplished, as well as a very simple way to use our product. And to do that, I'm going to go through and do a quick demo of uploading a file here. So the first thing I'm going to do is pop over into our product, go to our bucket. This is not the way you need to interact with our network, but it's a way you can interact with our network. So today, I'm just going to go into this bucket and I'm going to put in a super secure passphrase. I'm going to understand that I need to remember that passphrase because I'm the custodian of it and the service will not remember it. I'm now in the bucket and I'm going to upload that file. When that file uploads, I'm then going to create a share link, paste that share link in, and view it. Now, this is an edge service we're running that allows you to share out items to anyone you wish. And I'm just going to post a link so Heather can post that link for you. And you can load this link, but this is, and it's hard to see, on 80 different, there's 80 different pieces, so 80 different nodes. You can see the distribution around the globe of those pieces. And it's that easy. To show you what we've accomplished with the Internet Archive, I'm going to actually go through the root of their site. I'm going to pop into the book collection, and then I'm going to go to their most popular book, The Art of War. The Art of War, for all of us that haven't recently read it or are unfamiliar with it, is a book really about avoiding war, right? War is failure. This is about taking diplomatic ties to dispersing conflict. So with the Internet Archive, we've uploaded these 16,000 plus assets. And thanks to Arkadiy, you can see that all assets related to this asset are available over at STORJ and soon will be available at the Internet Archive. So you can see how they're using us. It's a programmatic interaction, so they're able to batch upload. You can see how easy it is to just use our simple web UI to go through and upload an object and share it. And that is backed by a decentralized network. I'm going to hop back to the presentation and then hop over to the next slide, which is a summary of what we've accomplished. A summary that you can stream on the right here. You can see what it looks like. We've made a mock in the center, as well as the list of items on the right-hand side. And then I'm just going to jump to a final slide and cover a few more things about the network. So what we're really excited about at STORJ is that we're given the creative freedom to produce what we need to be successful. That is, to build what people want. So when we're talking about things like IPFS, and Heather, I'm going to send you another link to share. This same image that we just uploaded has also been shared via an IPFS hash. I've sent you a link, should be embedded in the chat now, the IPFS demo.dev.storj.io, showing that not only is our storage decentralized, but content addressable as well. Now, that's something that's not in production today, but it's coming very soon. It's just so fantastic to be in an org that's provides so much opportunity to build great things for tomorrow. As far as a little bit more detail, I see a question on how does distribution occur. We had a PhD economist actually build the model, right? So all of the nodes on our network, we don't run those nodes, by the way, those are people that come in and choose to run them, are incentivized to be good actors on the network. We can't trust that they will be, of course. So we have a audit and repair process that continually runs. That audit and repair process means that if a node drops off the network, or a node is misbehaving on the network, or a node is simply just performing poorly, the power is out. We can address that. We will manage all repair. We will manage all audit. There's no need to negotiate, for instance, and have maybe inconsistent pricing. You pay one price. And all of that is done behind a service level agreement, SLA, a contract where we guarantee a level of service to you. So we are a product today that you can use in your production application. You can get the benefits of that global distribution. If you want to be distributed yet have data sovereignty, we do that as well. So if you, for instance, are trying to seek GDPR compliance, you want to be decentralized in Europe, you don't want the data anywhere else but the European Union, no problem. Conversely, if you're doing that in the United States for a reason, or Canada, no problem. So we're really today the only provider giving you that decentralized storage solution with data sovereignty story. Highly usable decentralized storage with multiple on-ramps, making it easy, as you've seen, for the Internet Archive to decentralize that large catalog of audiobooks. It's truly wonderful, and I'm very fortunate to be here. Wendy, with that, I'm going to wrap, and we can take care of the rest, of course, in QA.
Great. Thank you so much. Let's call Arkadiy and Dominick back, and we'll stop sharing the screen and answer a few of your questions. So one of the questions is, how can you really prove back from that hash that the originator did not fake the location? I guess, how do we know that the hash is really trustworthy?
As per Jonathan Dotan's conversation presentation, you're very much right to ask that. So the hash is only as trustworthy as the context of its creation. So obviously we end up with a certain needing to establish a root of trust. One way that I can see this working out is if you can imagine the Internet Archive as a catalog and as a data store. So right now you need both places. Archival bond, I'm actually not familiar with this term, but so imagine the catalog and the data store as sort of separate ideas. So if you trust the catalog, you don't necessarily have to trust the data store as if they are linked through a cryptographically secure hash. So you can imagine, for example, a censorship-resistant Internet Archive where you only need to ensure the integrity and transmission of the catalog portion, and then the data can be retrieved from any number of decentralized networks underlying it, and that relationship is trust.
So here's a question about decentralized storage working with digital preservation. How does it handle, for instance, file obsolescence?
File obsolescence. So let's dig a little bit deeper into that. That is the concept of a file not being necessary after a period of time. Is that how we want to think about it? Or are we thinking about the concept of maybe like bit rot?
I would guess the first, and maybe Dina can help us there. But let's say you don't need this file anymore. It's defunct. How easy is it to get rid of files, take them down? In other words, is it like Glacier, where it's really hard to move things around, or can you call and change things kind of at will?
I can dive in on that. So at storage, we say it's hot storage for the price of cold, right? So you don't have to deal with the tiers. There is no, for instance, auto tiering or lower tier layer. We won't let you erase your code to non-ideal ratios. We just do it right. That being said, however you handle your file management, and this is true for all storage backends, will be how you manage the archival and potential deletion of assets at a period of time. The storage backends generally wouldn't be responsible for that. It would be the data management layer, the front end that is managing that archive.
Well, with that, I think we are going to wrap up this session and ask everyone to join us at the next session for, more to and fro. We hope you did enjoy what you heard today, and it was just a taste, a beginning. So please come back for more. We're doing this for 6 months, the last Thursday of every month. This is number 2 at 1 p.m. Pacific, 4 p.m. Eastern. We have 4 more sessions. Here are 3 of them. The next one in March is on decentralized identity. And we've also, as mentioned, developed this really beautiful resource guide with different videos, links to other companies that do this, other organizations, deeper dive reading. So please take a look. We're dropping the link to that in the chat. It will be emailed to you if you registered for this, and please share it widely. That's why it's there. Finally, I just want to say thank you.